The key identifying feature of double replacement reactions is that you start with two ionic compounds. So in this sample, we have barium hydroxide and sodium sulfate reacting in a double replacement reaction. I'm going to start by writing them both out. Barium hydroxide is going to be Ba bracket OH bracket 2. It is going to be aqueous, and states do matter in this one. Sodium sulfate is going to be Na2SO4 because sulfate is SO4 2 minus. This is also going to be aqueous. All that we're going to do for the double replacement is we're just going to trade everything. So we started with barium hydroxide. We want to exchange the same things, the cations or the anions. Doesn't matter which one you pick. I always exchange the cations. So I'm going to flip the barium and the sodium. You always have to flip ions of the same type of charge, positives with positives and negatives with negatives. You can't stick the barium and the sodium together. You have to exchange them because they both have the same type of charge. So if I started with barium hydroxide, I'm going to end with barium sulfate, BaSO4, and I'm also going to end with sodium hydroxide. Now you'll notice I haven't written the states on these and I've left a little bit of space for them. What I need to do now is I need to consult my solubility chart and see which of these two is going to be solid. So on my solubility chart, I have a soluble row and I have a non-soluble row. For sulfate, I see that the soluble row says most. Okay, so odds are it's non-soluble, but we have to check. What are the things listed under non-soluble then? Well, we see that there's silver. We see that there's lead 2. We see, oh, sorry, I was looking at the wrong row. Okay, let's try that again. We see that there's calcium. We see that there's strontium 2. We see barium. So this is going to tell us that our barium sulfate is going to be a solid. Okay. Then, just for completion's sake, let's take a look at our hydroxides. Under soluble, we have group 1. We have NH4+. We have strontium. And we have barium listed explicitly. Okay, so this means that this has to be aqueous. Now we have to do a bit of work to balance these out. So I'm just going to get rid of this down here so we have space. There we go. Okay. We see that we have barium. We have hydroxides. I'm going to leave it just as OH because I can. We have sodiums. And we have sulfates. We don't want to split any of those up because that's going to make our lives more difficult. 1 barium, 2 hydroxides, 2 sodiums, 1 sulfate. 1 barium, 1 sulfate, 1 sodium, 1 hydroxide. Okay. Looks like we need to balance out our sodiums and our hydroxides. Lowest common multiple of 1 and 2 is 2. So we have to multiply by 2 and put in a coefficient of 2 for the sodium hydroxide. That changes the hydroxide. It also changes the sodium. Everything balances out now.